Here we go. There we are. OBS, I don't know, sometimes. Okay, welcome back. It's been a while, I know. Last week was not good for me. Unfortunately, things happened. But I'm back. And so are you, so welcome back. And thanks for stopping by. It's nice to see you. Let's continue on with our little experiment. We are working on GUIs. That's right. And we were working on adding a GUI to a text adventure game engine that we developed for the console, right? For the terminal. And because we're a curious sort, we're trying out different GUI libraries. I'm going to just set up my file watcher here. What was that error here? Oops. Sorry, it's just file watch. Typing what I say. This happens sometimes. Anyways, we're trying out different ones. We're trying Qt. We got pretty far with Qt in the last session, and I think it was like our first sit down with it, and we got pretty far, pretty quick. Now it's probably a little bit because we had experience building on Monomer and how to like add a GUI to this project, so we're going a little bit faster now, picking up speed, and so far fairly similar-ish in some respects, different in others. And let's just take a quick gander, a reminder of what our project looks like so far. So go to Adventure Engine. All right, and we can exec engine.exe or -exe. Yeah, there we go. This is as far as we got with the Qt version. There's a couple more things we want to add here. One, the formatting on this is pretty terrible. We're going to have to manage our own kind of like text buffer here and printing out our rendered scenes to this buffer. This is where we're going to take input. So like the user should be able to type like walk front door, press enter, and update the game state. Render a new scene, clear out this widget, ready for new input. And the last thing we'll need to add is like a little error message area underneath here to kind of hopefully get up to par with the features that we had in the Monomer branch, which is available on the repo for the project at Adventure Engine under my name, Agent Ultra. So that's where we're at. Well, let's see what we can do. Yeah. Well, we don't technically have that yet. Yeah, okay. Let's start a little heading for Qt. We're going to fix the formatting, scene formatting, user input, and errors display. We don't have to do a whole lot for error display because for the Monomer version we didn't really either. We kind of cheated a little bit and just used the show instances, but we should probably get close to feature parity before we kind of conclude this with Qt. Qt is the library we're using for this, by the way, in case you're just catching up and joining me for the first time. Okay. So let's go to the source, adventure. This is the GUI code we have so far. Very, very minimal. All within our Q application. Almost C++ plusy looking. Okay, cool. So, what do we do about rendering the scene? Because the scene should have new lines in it, and it looks like this is not respecting our new lines. So we might need to look up some documentation on Qta or Qt and see what we can do about that. Bring a browser window up here. And it's the QText edit. Yeah, we'll look in this repository for it. Okie doke. It's under widgets.qtext edit. This one. Okay. Accept rich text. Not sure if that'll be a thing. What's involved in rich text? Just have a lot of money? Or what? We have anchor add append, clear copy. Ooh, one thing we didn't check is can the user accidentally edit? Oh, and we set it to read only? Yeah. So we do use that. Okay, that's good. Clear copy. Looks like we can do some font stuff. That's pretty nice. Insert plain text might be what we want, maybe, unless we're already using that. No, we're using new with text. Okay. Let's try, what does set plain text do? Let's just use new. We'll QText edit, set plain text. That. Of course, that's going to be a type error. Couldn't match expected type. IO something something. Okay. Set plain text. QString avoid T. Oh, right. It needs the widget. Right? That's right. Okay. So what does that look like? That's better. Pretty much what we want. Okay, one more thing we should check is that we can render multiple scenes in here, because we're going to want them to list out. So while we can just hard code that for now. I believe we do that in the game state. If we got this up to speed with, yeah, the game state scenes. So this is the list of text. The default game state here. So we can insert a bunch there. Cool. Run it. No, it's not showing there. Up, 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 up. Oh, because we override that when we initialize the game. Don't we? Yeah. Yeah, we do that here. So let's just display the same scene twice, just for testing purposes. Actually, we should probably also checkpoint here before we get too far into it, so we can back out easy and make a commit. We're not in any trouble yet, but okay, yeah. There's like a little. Should probably have like some kind of divider between the two. We automatically get like a little scroll bar here for our stuff, our scrollable area, which is nice as well. Kind of expected. These Qt widgets. Okay, that's looking all right. So like I was saying, create commit there. Modify that one. Under the scene, it's plain text. Text widget. Cool. Now, since we're rendering the two there, I see. So we're using the unlines function to concatenate all of our scenes in the game state together to render into the plain text of this widget. We probably want something like unlines, but just to put like a little divider between it. This seems like the right place to put it since it's handling all the rendering for this project here. So cat scenes. Yeah, list of text. Just one text. We can intersperse that, I believe. Is the first thing we want to do. I think it's called intersperse. We've used it before. Some kind of text delimiter. I don't know if we know how wide it should be. We still have to do something with it, which is t.onlines. That's not in scope. And probably data.list as well. T? No. Intersperse isn't the right one that I'm thinking of. Perhaps. Data.list, where are you? Yeah, intersperse. Oh, I gotta give it an argument. I haven't given it an argument. Oh, I gave it the argument. And the list of A. Yeah, that is kind of what I mean. Oh. Is it because you think this is... It's been a long day. I'm not quite as fast as I sometimes am. Ooh, I had to wake up super early in UK time to get into Haskell X to see Simon Peyton Jones' keynote at 4:45 a.m. my local time, which is super great. I don't think I've ever willingly been up that early, so you're welcome, Simon. I was there. You couldn't see me, you couldn't see the gratitude, but it was a good talk. Okay, so we expected the type list of text to text, list of string to text from this. Do I not have overloaded strings enabled everywhere? Is that the problem? Probably should. What? How did I get... Interesting. And now I'm getting ambiguous type errors. Because this expects it to actually be a string. Let's do this a silly way. Wow, okay. Yeah, sometimes still kind of a pain point in Haskell. Strings, text, lazy text, byte strings, lazy byte strings. Seen it a few times on a couple of our projects, and it happens every now and again. I think Qtalk could be, maybe we should be good ecosystem Samaritans and give them text instances for some of this stuff. How hard could it be? But anywho, let's see that working, and then we can call that done. There you go, a little star divider. From porch. Okay, cool. So we know we can render multiple scenes with our little divider here. And that should be good. I might even want to put... I mean, that looks pretty okay. Not the greatest, but... Might even want to put like a little new line on the end of that one, but yeah. Let's do that quick. Will that be interpreted properly? Yeah, there we go. Cool. Yes. Done. So. Let's get rid of that hunk. We don't actually need it. We're just using that for testing purposes. Kind of makes sense for this to be there. For now, at least. Yeah, let's check it in. So we're going to add, this change when applied will add a divider between rendered scenes. Cool, cool, cool. Okay, to do, boom. That one's done. That one's to do, and that one's to do. Let's check on user input. How do we do that with Qt? I am not 100% sure. Having never done it before, but we shall learn together. Does the Qt documentation help us out here and tell us what to do? A great question. Just tells us how to build it and all that sort of stuff here. Signals, I think, is the general gist of it. Signals are represented by signal objects in the module for defining class, or the defining class. Okay. So objects returned from constructors are not garbage collected by default. Okay. All right. Okay. Yeah. All right. Okay. Just getting distracted with reading that. Signals. Okay. Q line edit. Let's check it out. Okay. Make signal. Got it. All right. How do I use these signals? And are we... Which are we using? Input area. We are using a line edit. Okay, cool, cool. So it should have those signals there. Text edited, text changed. Maybe we can do the same kind of Elmish architecture where we listen for text changed and update our own internal buffer. And then check return pressed to tell the game state to do a cycle of our REPL there. Eval the new game state, render it, all that kind of stuff. Seemed like a pretty good pattern, so why not? All right, text changed. Make this a two-parter. Let us user input buffer. And input submit or whatever. Okay. Input buffer. Let's go to the game state. Let's add one. Game state input buff. Just make it a text for simplicity's sake. That should be state world. And our default game state here. Input buff will be empty. Right, and then we have another type error there. Yeah, because we updated that to state world. Cool, cool. Add user input buffer to game state. And then I'm gonna hook up some kind of handler to this signal. Let's look at some examples. This looks like the state of the notepad. Right, the text that would be in it, or the text widget. Cool, cool. Okay. We got a menu. We can have a menu bar for our game engine. That's cool. Of course you can. And probably context menus and all kinds of stuff we could add. Let's see here. There we go, on event. Okay, so void on event window. Takes some, just a type, the type of the event, and gives us a block here to do stuff with it. All right, see if we can kind of mimic that in our GUI. I don't know, here seems fine. On event. On event for the input area. I'm missing some imports probably. The function. Some thing there. We got a do block. This actually is not quite right. Perhaps that should be that, like that. Yeah, it's an illegal type signature. Yes, we know, we know. Q close event. Okay. Oh, there's also a connect thing from qta.signal. Ah, this might be what we want. More like this. So let's abandon that. Try connect. Hey, Jason Odenberg. Hiya. First time here. Welcome, welcome. Nice to meet you. We are building we're trying out different GUI libraries in Haskell for our text adventure game engine. And today we're trying out Qt, seeing how that goes. Thanks for popping by, Jason. Okay, so menu edit. This is going to be our line edit. Something triggered signal. Signal. Looks like we take some kind of callback function that does something. So I'm just going to leave all the holes in there and just kind of fix them one by one because I don't really know what should go where or anything like that. I guess connect input area is probably what we want. Okay, it takes a widget, I guess, as the first argument. Or not. Not very helpful, connect. Not very helpful. What's the type of connect? Some object. Some signal, some handler function. Okay. So I think object, yeah, that seems right. To put the input area here. And then we need some kind of signal thing here. And then some kind of I/O effect. Potentially. Okay, how do I make a signal? Triggered signals, what we're using in the Notepad example. For all of those. Q action. Oh yeah, maybe that'll work for us too. Oops. We left that in. We should just get rid of that while we're here. Graphics UI, Qta, widgets.q, action. Triggered signal. Okay, maybe we can put triggered signal in there. Okay, sort of happy with that, except for connect's not in scope. And I think that just comes from I'm messing all of my key bindings up here. What the heck's going on here? There we go. We just saw signal, I think it was. No, qta.signal. Connect. Oh, what did I reject? Okay, no instance for this generated widgets queue action or queue line edit. Okay. Doesn't quite work. Oh, maybe that's defined in that widgets module. That might be a thing. Queue line edit. Text edited. Text changed. Oh, we have that right there. There we go. Text changed. Text changed signal. That seems like some kind of convention for generating these. Maybe like this. No, text changed. Queue line edit, yes. All right, there we go. All right, we figured it out. We don't need this one anymore. Happy without it. And all right, let's try it out. Okay, cool. So every time we press our key there, we're getting the woohoo action printed out. So we should use that action there to update the user's input buffer instead of like printing out all this nonsense. But we are nearly there for that. Super duper. Okay, so GS. How do we change you? You are a happy little pure little thing. All right, so that means we can't mutate it, which is Haskell is quite famous for, but we are not stuck. It just means we need to make some kind of mutable wrapper around GS that we can modify. And since we're already in the IO scope, we can just use an IO ref for that. I think that'll work just fine. So leave puts through lane there so we just don't have a broken program for the moment. Okay, let's commit that as well. When applied, this change will connect queue line edit, text changed, signal, handler. Okay. So IORef. Where is IORef again? There we are. Happy little IORef. So we need to change GS into a bind. And IORef gives us a function for creating them. New IORef with an A. Then we get back an IORef of A. With our initial game state. So now we have a type error here because GS is no longer the game state, it is an IORef. So we got to get the IORef out first before we can do that. So we need to unwrap that. We have it available as an IO action, basically. And yeah. Basically, we gotta read it out and then render this. So it's gonna, like, you can kind of uglyify it like this. Read IORef, GS. I'm gonna call it GSRef just to make it a little readable. Then we can do this. And that should be fine. Okay, and now this connect handler can modify that IORef when we get the changed signal. For now, I think we'll probably get passed in something. I don't know what type it is or what we can use it, but for now, just the simplest thing we can do is just print some garbage to it, just to make sure that it's working. So let's do that. First, we will get our game state out of the IORef by reading it. In fact, we don't have to do that. We can just use modify, right, to do it, mutate the contents of it. So the strict version of modify IOF is what we usually want. This little tick here is kind of the convention in a lot of libraries for denoting the strict versions of some function. So that will take our GSRef, an action to mutate the game state, and that's it. In fact, we don't even need the do there for that. Okay. So we might do it like this, where we could say GS, where we have the game state input buffer equal to the game state input buffer of GS. And we get append on F, no matter what we press. Or input buff, I called it for short. Because the C hacker in me is coming through. I apologize. That doesn't need to be ++. That needs to be there because it's a text. Okay. that's a shadowed binding. And that should do that. Okay. Let's check how that works. Oh, of course that always worked. So let's just print. Yeah, let's modify it in place. We'll get it back out again one last time, just to print it out. Just purely for debugging purposes. We'll remove this code once we're good. I think we have a show instance on it. Oh, we're missing a do now because we have that GSRef. That's got to be a show, which we don't have a show game state. Okay, so we should probably add that maybe if we can. I think we can, as long as we can for command. Ooh, command doesn't for reasons. That's no problem. We don't need to show the whole thing anyway. We just want the game state input buff. Buff. Oh. Any problem with this? It's a text. Pack. Unpack. Okay. That should be good to go. There we are. That's our input buffer. It looks like we get... Of course, we're... I kind of expect this to be accruing the Fs. Interesting. Right, because we get the input buff here and we like concatenate it with this like hard-coded F. Oh, because I'm getting from GS. I'm shadowing something here. Yes, this prior readout here. So, not the right thing. Subtle bug that you can sometimes get. There we go. That's what more like it. Alright, awesome Pyramid of Doom. Okay, so we're getting the input events, and we have our IOREF here being modified. Let's see what we get here. This foo thing. Yeah, whatever. It's just debug code. Okay, we get the whole string of what it's at changed to. Oh, look at that. Making little patterns here. Alright, that's good. So instead of hard coding at that, we don't even, we can just completely set it to whatever the input is. Of course, we gotta pack that back up into a text. We don't need to do anymore. Okay, so then our input buffer is going to be filled up with whatever we type in here. The other thing we want to have happen, that's part one of our input handling. So let's commit that. We're going to have to take a little cleanup pass maybe on some of the code here, but it's not too bad yet. And we are going to say that when we apply this change, we're going to wrap game state, the initial game state, and then IO_ref, signal handler, line editor, a QLine edit, next changed event can mutate the input buff. Boom. And let's go to our to-do file. Mark that as done. Now we want to submit the input. So now we want to, when we need to connect a new signal handler, which we figured out how to do. So let's go do that. Connect input area, QLine edit. Was it text return? Signal? Something. Probably not the right thing. Text edited, text changed. No, it was return pressed. That's the one. Return pressed. Doesn't get, okay, doesn't get an argument when return is pressed. Just an IO action. Okay, I'm just hitting enter here, as you would. All right, we're getting hoo boy. Hoo boy! Yeehaw! Okay, that was weird. Sorry. Okay, we got hoo boy. Pressing enter. GUI action. We're going to need to do a couple of things, I suppose. First, we're going to have to take a reference to our input buffer to process in our evaluation step to get a new rendered scene to add to the game state's scene references. So let's pull the game state out of the IO_ref because we're gonna do some stuff with it. We're gonna do a few things with it first. We're going to yeah, we're gonna have to get the new scene. Let's go to the engine. And we use the what's the function we use to update the game world? User input. Handle. Okay. enough. Okay. And we're basically going to kind of mock, we're going to kind of basically take this code here to figure out what we got to do to update the world here. So let us case handle prime of the GS, or what was G in this scope here? Game state, yeah. And world, current version of the world, which handle can actually technically get out of game state. We're going to pull it out here because we just don't have that yet. We could add it. We probably should, really. Remember, oh yeah, we have to remember that GS is shadowed. Gotta be careful because we did kind of load it here. So we should probably encapsulate that somehow. Get rid of that problem. However, so when we handle this, we get an either. Something to do in the left-hand case. And then something to do in the right case, we get a new world. Okay, we try to render the world. Almost verbatim. So let's just pop that over there and just fix it. Pop, 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 pop. Bazoom, bazoom, bazoom. In the words of the Great Master. Let's just put Sterlen the error there. We could do that here as well. Just for now. And then when we get the rendered thing, we have to update that widget. No, we have to add the rendered scene to the game state. Re-render that widget. And empty out the input buffer. That's what we need to do. Okay. So let's add GS prime prime. Where game state scenes is equal to the game state scenes of GS prime. And we're going to add, let's cons it on. Okay. Then we re-render the text. I think we can do it like this. Maybe Q text edit. Let's see if the setter will just overwrite the whole thing. And scene. We're basically going to duplicate that entire line. Of GS prime prime. What's the problem with that, by the way? We forgot to give the input to it. Yes. Game state input buff. Yes, that could be print. And that could be print. Okay, that's better. Squiggly's gone away and not distracting me anymore. So we set the context like that. Is there a method for clearing our line edit thing that we could just use? Or do I have to update its state internally somehow? Cursor stuff, mutating the cursor. Clear. Okay. That looks like what we want. So let's do Q line edit. Dot clear. The input area. Boom. Okay. Let's see if this works. Lock the front door. There we go. We're in the main hall. Okay, lock the door. We're running into some state management issues. And I know exactly what the problem is. We didn't update the game state and then save it and save it in the IO ref, back in the IO ref. But we're close. So that's one thing we're missing here. And the other thing we need to do with GS prime is set the game state input buff back to the empty text. That should be fine. So then we can write our IO ref. With our new value. GS ref with GS prime. Oh, we probably need the next state of the world as well. Game state world equals world prime. There we go. Okay, so we walk to the front door. We're now at the door. We walk back to the door. We're back on the front porch again. We can pick up the shovel, the purse. And the purse is no longer there. Yeah, okay, cool. Awesome. Hey, Sibnull. When do you use let and when do we use where? That's a good question. And it's one of those things that doesn't have an answer other than style and taste. I guess in practice, if we're just looking at the code I just wrote, I tend to use let for binding variables that I'm going to be using immediately within the block, and I tend to use where for functions. Not always the case, but I guess just looking at what I've wrote, that seems to be the case. But they're fairly similar. I think there might be some, I can't remember exactly what they are off the top of my head, There's some like scoping things that can happen with wheres that don't usually bite you, but they're pretty obvious when they're there. So I guess lets are just easier to use stuff that's already in scope when you're just binding like a new value kind of thing. Hopefully that answers your question, Sibnil. It's kind of a matter of taste and just experience as you go along. Okay, so that's that. Let's commit it. This, when applied, this change will add input handling. We update the game state according to the user's command. Re-render the scene. And all that jazz. Okay. So going back to our to-do, we're done this part. So we're done user input. I think this commit, let's see, let's find the way it is. And the rest of these are all related to, related to that to-do item. So I'm just gonna rebase all these and squash them down, basically. There we go. So we're gonna user input handling. So we accept input from the Q line edit widget. Update the input buffer, the game state, re-render the scene, and update the game state. And the user presses the enter key. Cool. Yeah, it's not a huge, it's mostly a matter of taste. Yeah. So hopefully that makes sense. I don't think there's any right way or wrong way. But the right and wrong way is going to be like what your code reads like and what makes you happy with it. Okay, so that's that. Done. Then we just have to render errors. And that's pretty good. That'll be Qta. So for errors, we kind of cheated a little bit on the Monomer branch. And we're going to pretty much do the same thing here. We could probably take a little bit of a cleanup pass on this first. Before we do that, just to make it a little bit easier to work with. So let's go into the GUI code. There's a couple of smells I saw here with the name shadowing and binding and things like that. So let's create a function for re-rendering the scene to the scene widget, the widget that's going to hold our scene. And what's that going to look like? That's going to take our game state. It can take our... you could take an IO ref to our game state. You can take the widget. Forget what the type of that is. I'm going to put the wrong type in there for now. Just so I get a type error, and then GHC will just tell me what type it should be, and I'll just fix it. And so that int is going to be a placeholder for the widget. And this is all going to happen in IO unit. We don't need to return anything. We just need to mutate that widget. And what that's going to look like is basically those two lines. Bring that into scope. Scene into scope. And concat scenes we have to move down here. It makes a little more sense. And that type error is going to go away in a second, so let's just comment that out. Line 28. Oh, we used it twice, didn't we? So we're going to replace this whole thing with our call to our new render scene function. I'm just going to take our GSRef and scene widget. We're just going to give her a type error. All right, it's not int, it's q text edit. That seems happy. So we can replace this commented outline with the same thing. Render scene with GSRef and scene. Get rid of that. Okay. So that should get rid of our annoying shadowing variable error that we were mistakenly making there. Okay. What else can we do? Well, error handling is going to be next. We're going to be handling those left cases, basically. So we can't not doing anything with that here. I'm wondering if we can replace these lines here with just like a modify call. Since all we're doing is just writing IORF the new GSRef. Then yeah, maybe like a little function, because we're going to have to pass in a couple of things to that modify callback. So we will just call it update game state. Which will take the rendered scene as a text, the updated world. I don't like these bare arguments, but we'll get to that in a second. And the IORef game state. Bring an IO unit. We will basically take this here out. And GSRef. Okay, so update game state now. We can just we're just shuffling around terms here, and just wrapping over all of this expression. Rendered, it needs to be in scope, and yeah, we're gonna fix this. So we're gonna have to modify this a little bit to make it work. I'm just gonna call world there, and we're going to modify IOREF strict with game state. No, we don't need to do that. It takes a function, GSRef, sorry. And we give it our function. Which is essentially going to be this expression here. We don't need that. Don't need that. GS, don't need to prime those. Don't even need to do. Okay, let's just make sure that actually works as intended. Oh, still have the game running in the background. Oops. We're gonna lock the front door. And I walk back to the door. Cool. Pick up the purse. Pick up the shovel. Yeah, we're good. Okay, so that works just nicely. And not a huge fan here. Like I said, we can actually pull the world. I think we can pull. No, we can't pull the world out because we get a new world back. Here, we do have to pass it in. I kind of want to do like a game state update. With a world and some text. Kind of like that. And we have game state update here. We can pattern match it out. Rendered scene is really what it is. And we can just bundle those up here. So we give our game state update as like one structure bundled together with everything you need to do to update the game state in this IO action. Roll prime and rendered. That's a little nicer. Okie dokie. That's a little bit of cleanup. When applied, this will refactor. In preparation, adding error handling to the GUI, just cleaning up some small stuff. To prevent errors. Okay. And so where we're going to store the list of errors in the game state, of course. So let's open that up in the engine. Game state, boom. Game state errors. We can actually just put those as game errors. And add that there. That should compile fine now, I think. Boom, boom, boom. So now, when we have an error case, let's add a new case for game state updates. Add game error. Game error. And then we just need a new case here for game errors. We still need to take our IO_ref of the game state, so this GSRef. And then we could do modify IO_ref, prime on GSRef. What do we do with the game state? Well, we're just going to modify game state errors. We're just going to concatenate cons on that error to the list. The error we got caused onto game at state errors of GS. All right. So also bundling up our parameters into a type like this, into a sum type like this, gives us a little bit of extensibility for these updates to our game state. We can kind of reuse similar patterns. We just kind of pattern match on which kind of update we want to do. And so we just modify the IO_ref in a very controlled kind of manner. And that should be fine. So now we just need to render them. Oh no, we actually need to call our update game state. In the error cases, we have our errors, our game errors. So the first one we have here, we call update game state with add game error. And, and our IO_ref, which is GSRef. I think this would be just slightly cleaner if GSRef came first. Let's do that. flip that argument around. Flip that around there. Yeah, that should all compile again. Okay, cool. Isn't that nice, actually? Right, we just flipped the argument order around, got a bunch of type errors, fixed them all. Now our program's compiling again. We can be sure that it's all copacetti. So yeah, make small changes one at a time, a little bit, but a little bit. So we update the game state with the game error, and we can do that here as well. I think the render errors are also game errors. And they are. Cool. And let's just, before we get into the widget, let's just double check that these are, I mean, they should be working just fine, but. Get in. How you doing? Thanks for the question. Thanks for joining us. When was the last time I cut my hair? This is like my pandemic game hair, I think. It's been about 1.5 years, I would say. So quite a while, maybe a little more than that. Yeah, somewhere around there. Vote. I think maybe we need a vote. I'm been thinking about probably we should get it cut at some point. But it's pretty metal too, so I don't know. Yeah, it's pretty long. Yeah, I used to, obviously. Well, not obviously to you, perhaps, but that used to be a thing I would do. Yeah, I just haven't been. I've been too reluctant with the pandemic and everything to do it yet. Oh, very good for you. I don't know if I'm willing to try that on myself. Let's see. Yeah, so I just want to test that we're actually doing. I think this is right, but baby steps. So let's just do something here, say. Read the IO ref. And print the game state errors or GS prime. It's probably what we actually meant. Yeah, I mean, that is a good way to save a little bit of money. It's true. I mean, there is something about going to the barber, I suppose. You know, my local guy is an older gentleman. His name's Tony. He's been doing it for a long time. And it's just something to do more than anything, or it used to be. His shop's still there. He's still taking clients. Like Tony's still in good shape, but a long-standing pillar of the community. Yeah, so let's just go ahead and try this out. Shout out to Tony. What's up, buddy? I know you're watching my stream, learning how to program in Haskell in your spare time. There we go. So there's our error, unrecognized command. That's not a verb in our game. That's cool. Can't do that. And we're appending all of these errors to a list, which is pretty cool. Okay. So our modification there is going well. Now we just need a widget to display them in, I suppose. So with our monomer version of this that we tried, as kind of our reference, we had like a little kind of text area list thing underneath the input area for our errors. I don't know how good that's going to look in Qt. It's probably going to look like garbage. But I guess we'll have to find out. Even if we have like kind of a minimal viable something. Should be good enough. I think we only, also in our reference implementation, we only take like the last so many errors to render. So I'm just going to quickly add take 3 onto that cons. Cool, cool. And now we should see when we have errors. Oh, I forgot to add, I took out the print. Ah. Boop, 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 boop. I'm gonna add it back in, no problem. And basically, we should only see like a maximum of 3 errors in there. 1, 2, 3. And then if I add like ZZZ, it'll be at the top, and Wefu will get bumped out. There. Cool. Super dope. I like it. Get back rid of that. Check it in. Create a commit. Well, we won't check it in yet, but we'll create a commit. So when applied, this update, this patch will add error list to game state. We get an error updating the game, and the error to the list. And the next part of this will be to render the errors. Should we do it with just another text area, mayhaps? I don't know. Let's see. Variety is the spice of life. Let's just use some other widget maybe. In something. That's terrible. I don't want that. Qta. Qta. Not that. Not. There's not that either. Where did it go? Qta documentation. Let's find us a widget we can use here. There's the API documentation. There we go. Oh my gosh. Qta, your API documentation is gone. What happened? Was it there before? I can't remember. Okay. This is probably the actual repository. This is no good either. Well, the nice thing is that we can just look at the Qt documentation, as we discovered on our stream last time. This library generates a bunch of code to bind to the C++ libraries almost directly, so why not, right? Widgets. All right, list view was one we investigated. Wasn't very good, but maybe this will be okay. Looks kind of like that. Usually use it for those kinds of dialogues. Maybe we can just put this collection of icons. Maybe not. It's a queue list widget. Some item-based list widget. Okay. No. Let's see how listly things. Line edit no, list view no. I mean, maybe we got to use this list widget and list widget item thing to do if we want to do like a list widget kind of thing. Maybe we should just do a text thing. What else can we find here? Tap gesture, no. Table. Yeah. Okay, let's just do it in a thing, like another non-editable text things. I don't know. I don't know what to use here. So many choices to make. And we found with like Qt that like the widgets don't nest in a tree arbitrarily. So unlike Monomer, where it's kind of like set up that way. So let's do another seam. We'll do like errors lift q text edit dot new with parent. Oh no, we just want it with new. We're going to set some stuff on it. Q text edit. Yeah, I don't know where. Meh. Anyways, Q text edit. Set read only. Errors list. True. And then qbox layout dot add widget to the layout with our errors list. Dang it, maybe we can like just fix the height of it if it looks kind of bad, which it probably will. And it totally does. So let's fix that. Text edit. Word wrap mode, no. So we set it to read only. How do we control what it looks like? Like I want to control its height. Signals. Maybe this is like a style thing we gotta do. Qt style height text edit. Qt style sheets. Maybe the example on Notepad has something like this. Connect a bunch of signals. Set up the menus. Maybe not. Yeah, okay. Anyways, we're running a little low on time because we're going to finish. I started a little early today. We're going to finish a little early today. Because I got to get up pretty early for Haskell Exchange tomorrow. But let's finish off. Let's just render that out. We'll figure out the styling at some point and make it look better later on. Let's go to the GUI. So we have the widget. And update game state's good. So we want to render errors function. So let's do that. IRF of game state. with whatever the heck it's going to be. It's going to be the same as the other one, actually. QText edit. Edit. QText. Edit. Okay. Worry about making it look better later. Let's just make it work first. That's the spirit. Text area. I don't know. What's called text area. And it's going to look very similar. Read IO ref. The GS ref. And QText edit. Set the plain text of the text area to t.onlines game state errors. Just that's not quite the right pipeline for that. We still need to map those to this show. Which we won't need this anymore. We could just use data lines from data.list. And that should be fine. Because all the Qt widgets take strings instead of texts. And now we have an error. It's not doing anything there because we're not actually calling this function yet. That makes sense. So in our error handler, we update the game state with the add game error, and we render the errors. The widget to render it to. And now another pattern is actually coming up to me that we could probably do a little refactor for to clean up some of this here. See if you can spot it too. There we go. We should never get more than 3, so that's good. Okay, and that's fine for that. Let's just do a quick little work on this. So we kind of have, I think we could bundle up some of these widgets that we kind of update when we also want to change the game's state. Because the thing we're doing here is we're like updating the state and then we're rendering. Updating something, rendering something, updating something, rendering something. It's probably fine. It's only like a couple of places here, actually. Probably okay. I don't know. It's not the best, but it's fine for a pretty small little bit of code here. But we might want to have like a type that kind of bundle, like a record that bundles up all those widgets. And then we can have like a function that takes that bundle of widgets, takes the update action, and does the things in one go. Well, this is fine. This is fine. It's okay. It's enough to tick off our to-do list item for that. Boom. So I'm going to rebase that. Rebase interactively. Why can't I type today? No. Oh, is that created commit yet? Jeez, Stream Brain is real. Add errors list widget. Renders the errors in the game state. Okay. That's why it wasn't working. Oh my. When we get an error updating game state, we can append the error to the list of errors. The game state. Renders the errors in the game state. Error list widget. Okay. Let's push it. All right. Qt branch feature complete. Doesn't quite look as nice as the Monomer version, but feature complete. To our reference, kind of like GUI thing on that branch. Only built with Qt instead of Monomer. Oh, gee. Final thoughts. What do we think about this project so far? Well, it's kind of, the Qt one's kind of ugly. I think it will take a little bit of work to make it look nicer. Figure out the right widget we could use for the error area. Probably add a nice little menu. It's like, you know, if we start adding save states and things like that. This text area seems like it can take even rich text. So there's a potential to make this look nicer as well in here. And it's pretty good. It's not bad. Not bad at all. Yeah. But let's take a quick gander back at the other branch for a little comparison. Yeah, we did one using Monomer, which we're going to just check out quickly here, just to compare what they look like. Okay, so when we started this, we started the exact same commit of the console version of the Text Avenger engine, and we added a GUI to it. And the first one we tried was Monomer, and which looks like this. Right. So more of a vector-based UI. With our own font here that we've created for it. We can expand the Brawly bucket, you know. Have some commands for that. Take a Brawly from the Brawly bucket. But yeah, you can see like the errors kind of under here. That's kind of a fixed size area. So it scrolls as well. Did I pick the background color? No, actually that's just the default, I think, for it. So it's pretty easy to style stuff in Monomer as well. It probably is decently okay in Qt as well. We just haven't dug into it quite as much. But the Monomer code looks like this, more like this. And it takes a more kind of Elm style approach to the structure, which we kind of had to emulate. We emulated a little bit with the Qt code. But there's nothing stopping us from taking a different approach with the Qt code. Whereas this is this seems fairly highly structured. Like Monomer takes our stuff as input and runs it for us. We don't really have a chance to do anything else. Right, like it takes our model, it takes everything. And it uses a lot of lenses and things like that for updating things and whatnot. Yeah, I think if I was going to take this a little further, I would probably be tempted. I'm tempted to stick with Monomer for it. Qt is cool, and you know, if you need to build native UIs or your Haskell applications, I think that has sufficiently demonstrated to me that it's very, very possible, convenient and not inconvenient at all. Like there's a lot of UI options for Haskell programs. But because this is a game engine and it's meant to be a game, there's just more creative possibilities here with the look and feel. Because underneath this library is a very simple vector graphics library written in C. And a lot of these widgets I think are just defined in Haskell code. And some of the code for defining your own widgets is pretty straightforward. You have to do all your own state management code, which this is all in pure Haskell as well. As far as I can tell from just browsing the source of Monomer. Yeah, there's just more we could possibly do there. And since it's kind of also running this, I think on a using SDL2, like on a GL buffer, like there's potential to do other like graphical things and whatnot. Yeah, so it feels a little bit like a lot more functional, like it fits a little bit nicer in the Haskell world. Whereas what we saw with the Qt code, it's, you know, it's wrapping C++ code, right? And it tries to wrap it almost one-to-one. So you get a very C++ feeling code when writing it. All right, so like all of our state updates here, you know, we can extend our own event types to our like kind of app-specific events, and that's how you hook it in there. Very Elm-like. This widget tree, very Elm-like. That sort of thing. So that gets all passed into Monomer and runs. Whereas if we bounce back to Qt, right, we're using pointers and IO refs. You know, we're using IO refs to maintain our application state and to mutate it, because everything is happening on the main thread here in IO. And it's nice. It's a lot of flexibility though. And it's really convenient, I think, too. Like mapping it one-to-one to the C++ classes is smart. It's what I would do. You'd have the opportunity to build some nicer interfaces over top, as we were kind of starting to abstract a little bit with some of this stuff here, and we might come up with a scheme for kind of doing an Elm-inspired architecture on top, maybe. But the sky's the kind of the limit when you're in IO, isn't it? So it was really fast to get stuff going in Qt too. Like, and I'm not sure it's because I did the Monomer bit first and kind of like felt I knew what we needed to be done. We spent a little bit more time in the exploration, kind of like, I don't know, phase with Monomer, but we did get most of the application kind of up and running in one session with Qt and Qta. So good to know that that's there. And of course, I think they're also, the Qta library is also wrapping a lot of the other widgets. So if you do need to do graphics and things like that, I think there are GL contexts. All those things that you need. Maybe it's Qt generator, I don't remember. Anyway. Yeah. Monomer, not as many, perhaps. I don't think it has quite as many. Let's see. So Qt only wraps, of course, the base ones. You get like the base Qt installation, which is still quite a lot, as we saw. Like quite a few of them. Right. Let's kind of get a rough idea. Like, I don't know, 200, maybe not 200, but like 100 maybe. A lot, right? But if we check out Monomer and what kind of widgets it's got, right? So it's got, it's hard to say like exactly, but this is kind of a rough comparison, right? Like not quite as many out of the box. You know, Basis only has one, so like, I don't know, a little over 20. But, and you get animations with it too, actually. We didn't try this out either, but some fade slides and things like that. Could be fun to play with. Well, it's also got the container ones. These I like a little bit nicer than the way Qt layouts seem to be done. Because again, we kind of were able to nest things into that tree structure. And even if we did something that seemed kind of like silly to do, it worked. So we created like just this V stack here is just a vertical stack. It's just a container widget. And just to contain other widgets and just lays things out vertically, whatever's in there, one on top of the other. And so we're quite literally generating a list of widgets here. Now, I don't know how efficient this is, but like under the hood, if Monomer is doing anything special here, but that's what we're doing. Regular plain old Haskell functions, just generating widgets, interspersing them with other widgets into our rendered widgets, and just kind of smucking them together. And then we can stick VStacks instead of other VStacks. So we had a VStack of VStacks in our widget tree. So our main widget tree is a VStack here, which has the rendered view label. So that's like our scene, all the rendered scenes, all the rendered errors, the input text field in the middle. Styling feels very CSS-like, so we just style basic with a list of kind of style commands. Does it feel a little, yeah, it feels a little bit web developy, a little bit. Yeah, so it's got most of the basics. It's a good start. And if you really need to do like those custom widgets, let's take a look at a little bit of that code there. Actually, it has some, I think it might have it in the documentation. Like that's their example to-do list app, and it looks pretty sick. Now, mine looks kind of iffy because I'm like rendering an OpenGL buffer over SSH using Xserver, which isn't going to show up super great, and it's over a stream as well. So what you're seeing is probably fairly degraded, even from mine. But it looks really, really nice. And creating your own custom widgets is definitely doable. So this is like the tutorial on custom widgets. These are kind of like tells you how to get going with it. But you get like this canvas idea, and you can just draw. All right, there's just some handling stuff that you can do, but rendering, like you can just draw stuff. Setting strokes, beginning paths, render lines, which looks a lot, if you've ever used like the JavaScript Canvas API, it looks very, very similar, I would say, or like any kind of turtle-ish, stateful, Canvas style graphics API kind of thing. I think SDL2, this might even just be using like down to SDL2 commands, I'm not sure, using the SDL2 renderer. But if I was going to do something like, I don't know, a DAW, like a digital audio workstation, you know, I'd want like a nice, cool looking fader kind of graphic to look like a fader. And doing that with vector graphics is kind of the standard. Yeah, so I kind of really like this library. And if I'm going to be doing that kind of stuff with it, I'd probably use this. If I'm doing something a little bit more like enterprisey, line of business oriented, or that needs to tie into kind of like another suite of tools that has like a particular look, I might go to Qt, depending on where I'm deploying and that kind of stuff. But for more creative projects, or you really need to dig in and build your own widgets, I'd probably go with this for sure. Or, you know, if that's just what you like and you like the look of it, you know, go for it. So yeah, that's the end of this project. Unless we decide next week to go with extending this adventure game engine and kind of just keep going with it and see where it takes us. Otherwise, we got to start looking for a new project to work on, right? And show more Haskell stuff that you can do. I don't know. I'm going to put a poll out. Maybe I'll put a poll out on Twitter, or if you check out that Discord invite link and get it invited to the Discord, join our Discord channel, you know, and there's our channel there. You can some pre-chat with me there. I'm also on the functional programming Slack community and the Zulip server, and on Twitter at Agent Ultra. So a bunch of people I'm following, probably tweeting stuff. And yeah, that's me. So give us a follow there. I'll probably put another poll out and give you a couple of ideas for some projects that we can work on. I was thinking that we might even just use Monomer and start building some Haskell tooling with it. We were doing some profiling for Replicant and noticed that the visualizations, we're getting like the visualization of a Haskell heap, for example. You kind of have to like run through all these silly PDF tools in the command line. It was terrible. Maybe we want to write our own little heap visualizer tool. Again, we can dig into the custom widgets and kind of build something like that. That could be a thing. People like compilers. Maybe we could do a compiler project. I don't know. The sky's the limit. So keep an eye out for that. May your types always check. May your monads always be free. Thanks for coming by. I'll see you next week. Usually I stream Tuesdays at 8 o'clock in Eastern, well, daylight time now. So we'll see you then. Peace.